Hello everyone, welcome back. Our today's session will be on Introduction to Network Forensics from the module Network Forensics. So in this video, we'll start with introduction, then what is network forensics, purpose of network forensics, the process of network forensics, network forensic method, sources of evidence, and lastly, the need for network forensics. So let's start with introduction. Your server has just been wiped clean of all the traces of an attack by a cybercriminal. Isn't it true that you'll never know where the attack came from or how much damage was done? So imagine that all the records of an attack are erased from the server. And when the traces are gone, it seems like we'll never know who did it or how much harm was caused. So here comes network forensics. Forensic investigators play a crucial role in uncovering the source of the attack and assessing the extent of the damage. So the investigators use different tools to find the source of the attack and assess the extent of the damage. What is network forensics? Network forensics is a science that centers on the discovery and retrieval of information surrounding a cybercrime within a networked environment. So, network forensics is basically a branch of digital forensics which deals with the analysis of network traffic for investigating any cybercrime. And with the help of network forensics, the data can be retrieved, includes messages, file transfers, emails, and web browsing history. So next we'll see purpose of network forensics. Means the goal of network forensics. So the purpose of network forensics is to identify, investigate, and respond to network security incidents. Means it helps to identify and investigate any suspicious activity over a network. Gather evidence for legal proceedings. So it helps in collection of evidence which is acceptable in court. Trace the source of attack and attackers. Network forensics helps to track the origin of the attack and identifies the attacker by analyzing network traffics and logs. So next we'll see the network forensic process. Means how network forensic works. So the 5 key steps in the investigation are obtain, collect, analyze, and report. So in the first step, the investigators gather initial information about the incident and the network environment, like the date and time of the incident, systems and endpoints involved in that incident. Collect. So here, documenting all the systems that are used, capturing the network data, and gathering logs. Analyze. Here, different techniques are used to analyze the collected data. And lastly, investigators summarize their findings based on the evidence collected and analyzed in the form of report. Next point is methods. So network data collection is a primary step in network forensics, and collection happens in 2 methods. Stop, look, listen method and catch it as you can method. So stop, look, listen. This method looks into each data packet on the network but only analyzes those that appears to be suspicious and which require some additional analysis. Next method is catch it as you can. So this method involves capturing of all the network traffic which is available and analyzing all of it. This can be a lengthy process and it requires more storage space. Next point is sources of network based evidences. So some of the common sources where you may find network data during the investigation will be discussed here. First is packets. So packets means the information or the data which is exchanged between the network devices, and some packet capturing tools are used for capturing those packets. Switches. So switches are used to connect the devices on a computer network, and it contains a content addressable memory table, that is CAM table, which maps physical ports to MAC addresses, and this helps to trace the MAC address to a specific port to analyze the network activity. Routers. Routers connect different networks together. So as switches have CAM table, routers have routing table. Routing table is a database which stores the path of the data packet over the IP address. So it can determine the path of data across different networks. So the next is firewall logs. Firewall basically controls the incoming and outgoing traffic based on the rules. So the logs record the connections, allowed or denied traffic, and rule violations. DHCP server logs. DHCP stands for Dynamic Host Configuration Protocol. It assigns the IP address to the networks, and during this some logs are created which includes the assigned IP address, MAC address of the device, time, and the system's hostname. IDPS alerts. Intrusion detection and prevention system alerts are generated when they detect any suspicious or malicious activity over a network. Wireless access point logs. So these logs documents wireless devices that are connected to the network. Email server logs. These logs save the data about the incoming and outgoing email traffic, including the sender and recipient address and timestamps. And the next is authentication server logs. So these logs maintain the records of successful and failed login attempts, which helps to trace the user activity and unauthorized access attempts. So the last point is need for network forensics. Network forensics can play an important role in protecting the networks from any malicious security threats. So it allows the organizations to investigate data breach and also to know when the incident occurred, how long the incident occurred, what data was taken, and how many systems were affected. So this helps to find the root cause of the incident. So this was all about the introduction to network forensics. We have seen what is network forensics, its purpose, process, methods, and source of evidence. In our upcoming videos, we'll see what is packet capture and network traffic analysis with the use of different tools. So stay tuned and thank you for watching.